Today's lesson's on inverse functions. Let's look at the steps for solving for the inverse of a function. Step 1, change f of x to y. Step 2, switch x and y. Step 3, solve for y. Step 4, change y to the inverse of f of x. So find the inverse of the function f of x equals 3x plus 7. First step, change f of x to y. Second step, switch x and y. Now we're going to solve for y. And our last step is switch y to the inverse of f of x. Make sure that you check. We check by taking our problem, 3x plus 7, and putting in y2, and our answer, x minus 7 divided by 3, putting those in y1 and y2. Finding an ordered pair, switching the x and the y, and then finding that switched ordered pair in y2. Okay. Let's do another one. Step 1, switch f of x to y. Step 2, switch x and y. Step 3, solve for y. And step 4, change y back to the inverse of f of x. And step 5 is check. Right. This time we have inverse of h of x, so we're going to change h of x to y. Switch x and y. Solve for y. This time I'm going to divide just a little bit differently. Instead of one division, I'm going to do each term. And x divided by negative 3. Negative 9 divided by negative 3 is positive 3. And I'm going to this time I'm going to switch y back to the, not f of x, but the inverse of h of x. Still going to check again. This time we have a fraction. Does that make it any different? No. Still doing step 1 the same. Still doing step 2 the same. Now, step 3. How do we solve for y here? Okay, remember, to get rid of a fraction, we multiply by the denominator. 2x equals 3y minus 7. We're going to add 7. And we're going to divide by 3. Then we're going to switch y back to f of inverse of f of x. And we're going to check again. We got a square here. Is that going to change anything? Well, it doesn't change step 1. Doesn't change step 2. So now we're going to solve for y. We want to add 9. Now, remember, opposite of squared is square root. So we're going to take the square root of both sides. Square root of y squared is just y. Now, square root of x plus 9 is just the square root of x plus 9. But remember, if we take the square root, we need the positive and the negative. And the last thing we need to do is change y back to inverse of f of x. When we're checking, we want to check both the positive and the negative here. Here's a couple for you to try. Now let's determine whether each pair of functions are inverses. How do we do this? Well, we're going to take the inverse of f, and we want it to be g. If it is, then we need to take the inverse of g, and we want it to be f. If they both work, then they are inverses. If one of them doesn't work, then they're not inverses of each other. So let's follow our same steps. I'm going to add 1. X plus 1 equals 2/3 y. Now we got a fraction. I know many of you don't like the fraction, but let's rewrite it. We're going to take y and we're going to put it in the numerator. So we have 2y divided by 3. Still got that fraction, but it's much easier. How do we get rid of fractions? We said a couple problems earlier, we multiply by the denominator. And gone there. On this side, we need to multiply every term by 3, so we're going to put it in parentheses. Let's distribute the 3. Now we're going to divide by 2. We have 3x divided by 2 plus 3/2 equals y. Is that g of x? It is. Now we're going to find g of x. Alright, let's solve for y. So we're going to subtract 3/2. Okay, now we need to rewrite this. It's 1, put the y in the numerator. Going to multiply by the denominator. We have 2x, subtract 3, 2 times 3/2 is just 3, times 3y. Now we're going to divide by 3. So we have 2/3 x minus 1 equals y. Is this the same as f of x? Yes, it is. So that means these two are inverses. Here's a couple for you to try.